In this lesson, we want to find the equation of the tangent line to the function at the point x equals -1. So the graph is probably going to look something like this. It's a power degree 4 positive leading coefficient, so both ends are going to go up. So we want the instantaneous rate of change at whatever point x equals -1. So remember that the instantaneous rate of change, let's say it's here. The instantaneous rate of change is the slope of the line that passes through that point. So the instantaneous rate of change is the slope of the tangent line. We want to find the equation of the tangent line. So we're looking to find not only the slope, but also the value of b. So m is going to be the instantaneous rate of change, which we will use using an interval table as we have done in the previous lessons. And then we will sub in the one point that passes through the tangent, which is at x equals -1. So I'm going to find the slope first at x equals -1. I'm going to approach it from the right side. So I'm starting at 0. And I'm going to approach -1, getting increasingly closer to that value. So I'm just going to put my calculations down here. So we're going to sub in f of 0 into the equation. We get a value of 2, and I'm going to sub in -1, and I get a value of also 2. So in that first interval, we have f of 0, which is 2, minus f at -1, which is also 2. That equals 0. Delta x is 0 minus -1, so 1. And then 0 over 1 is 0. And then I'm going to move that point a little bit closer to -0.5. I'm going to sub that into the equation. And I calculate a value of 1.8125. So we're going to do f at -0.5 minus f at -1, and we get a value of -0.1875. I'm going to do delta x, so that's -0.5 minus -1, so +1 gives me positive, so always be careful of signs. And then my slope of that tangent line will be -1.875 over 0.5, which equals -0.375. Then I'm going to move the point a little bit closer, this time to -0.9. Plug that into the equation. And so we'll have 1.8461 minus 2. And that works out to be -0.1539. Then we have -0.9 plus 1 is 0.1. And delta y over delta x will be 1.539. Then we're going to move a little bit closer. So remember that you want to use enough intervals that you start to see a constant result or a limiting value. So we've got 1.9849 minus 2 divided by 0.01, -1.51. So now I'm starting to see a starting to get close to a constant or limiting value. I'm going to do -0.999. Delta x is 0.001, and we get -1.995, which is a bit of a difference. So let's do one more. I'm going to add another interval. So remember, you want to see that consistency. So I'm going to do 0.9999, and it works out to be -0.000199995. And so now I'm starting to see that constant limiting value. So here it looks like the slope, well, let's write the instantaneous rate of change or the limiting value the slope of the tangent all mean the same thing. The instantaneous rate of change is the limiting value at x equals -1, and it is the slope of the tangent is equal to approximately -2. We'll round that to -2. So now we know the equation is -2x plus b. We want it to pass through. It only passes through one point, and that is at -1, 2. So this is my value for x and my value for y. So we'll put 2 in for y, and we'll put -1 in for x. Oops. And so b works out to be 0. So the equation of the tangent line is going to be -2x. Okay, so you're just doing one more step. You're still using the interval table to find the slope of the tangent line, and then you want to sub in that one point that goes through the tangent to find the value b. Okay. I think I did that on the previous page. So let's just write it out again. So remember that the equation of line is y equals mx plus b. So we found the slope to be -2x. We passed through the one point, and we find b. So we'll just write it out again. Okay, so that's just what I did on the previous page. So this is the equation of the tangent line.